Hello, welcome to my YouTube channel. Today's lesson is a continuation of my previous lessons on scalar and vector quantities. So this is a continuation of it. In the last lesson, I explained a scalar quantity as a quantity that has only magnitude and has no direction for its complete representation, and that a vector quantity has both magnitude and direction. So to continue with that, we are looking at vector representation. Now, the vector or a vector is represented by a section of a line, or simply call it a line segment having an arrow edge. Now, the magnitude of this vector is represented by the length of the line in accordance according to a specified scale, which means the magnitude of the vector is proportional to the length of the line. A vector with a greater magnitude will have a longer length of line to represent it, and a vector with a smaller magnitude will be represented by a short line. Now, the direction of the vector is given by the arrow edge of the line. So the arrow edge gives the sense of the vector in which the vector is acting. Now, take for instance, you have two masses, lying on a floor, and one of them has a weight of 40 Newton, and the other has a weight of 100 Newton. And the weight of the body acts at the center of gravity, the center of both masses. Now, how do we represent the weight? Weight of a body is a vector quantity. We need to use a section of a line. Now, first of all, I have to choose a scale. Here, I'm using a scale of 1 centimeters to 10 Newton. Now, which means a vector, a weight of 40 Newton, will require a line of length 4 centimeters, and that a vector of 100 Newton will require a line of 10 centimeters. So, which means, going by the scale I've chosen, I'll carefully draw on the first weight a line as long as 4 centimeters to represent my vector of 40 Newton. And then I will draw another line from the center of action or the center of gravity of my second mass. And I must be careful that the length of this line is 10 centimeters. So the length of this line is now used to represent the weight of this body, which is 100 Newton. Now, a vector can act in either in the northern direction or southern direction, eastern direction, or western direction. It can even act between northeast, northwest, and so on. In order to quantify the direction of a vector, that is to give a value to the direction in which a vector is acting, we use the angle that the vector line makes with the OX direction, that is the x-axis, as you can see in that diagram. The angle theta is positive when measured in the anticlockwise direction. One form of representing vector f is given by f vector equals f magnitude. Maybe you can place it like this: right or left angle bracket theta. We call this the polar form of representing a vector, polar form. So in this polar form, this is the actual vector, represented by this symbol in magnitude and direction. And this other one stands for the magnitude of the vector, and then this angle theta stands for the direction of the vector in degrees. So this is one way of representing a vector quantity. Now suppose this angle theta is 30 degrees and our vector f is 50 Newton, which means that in magnitude and direction, a polar way of representing vector f is 50 Newton in the direction 30 degrees. Now we come to vectors, symbols, and notation. Now, how do we identify a vector in a mathematical or physical equation? A scalar quantity is represented using either a lowercase letter or an uppercase letter with a light font. For instance, the magnitude of acceleration vector will be given as 5 meters per second squared. This is just dealing with the magnitude, which is a scalar quantity, because magnitude is scalar. Now, if I must represent a vector What are the symbols we use? Number one, we use a letter with a bold font. For instance, a force of 20 Newton due east is represented using letter F with a bold font. Or we can use letter F with just an arrow over it. Now, if the line segment is labeled, for instance, look at this vector acting from point A to point B. It could be a displacement vector. Somebody walks from point A to point B along this line, a distance of 10 meters. Now, what's the displacement vector from A to B? So the vector that is represented by this line AB is written as AB with an arrow above the two letters. And then this is the magnitude, this is direction, acting in northeast direction. Now the order of the arrow is very important, meaning that this vector is acting from A to B. If the arrow were to be like this, then meaning that the vector is acting from B to A, and such a vector will be written as vector BA. Okay, so note that vector AB is equal to negative of vector BA. That is, it is equal in magnitude to vector AB, but is directed oppositely. Now, if a lowercase letter is used instead, that lowercase letter must be written like this, having a bold font, or if I use a lighter font, then I must place an arrow over the letter A. So this is how a vector quantity can be represented in symbols, so that in any mathematical or physical equation, you should be able to distinguish between the vector quantity and a scalar quantity just using the symbols alone.